In November 1987, 34 academics, researchers, manufacturers, and representatives of agricultural organizations from 16 countries gathered for 2 days in Bologna, Italy, to discuss the state-of-the-art and prospects of agricultural mechanization worldwide at a symposium entitled Research and Information Spreading on Innovations for Agriculture and Industry in the year 2000. The setting was the 18th edition of the EMA Agricultural Machinery Exhibition, organized by the former National Union of Agricultural Machinery Manufacturers, now Federunacoma. And the aim was to create an opportunity for reflection and in-depth analysis to outline and broaden the horizons of the mechanical agricultural sector and strengthen collaboration among research, industry, and agriculture. The success of the initiative and the interesting discussion led the coordinator of the event, Giuseppe Pellizzi, director of the Institute of Agricultural Engineering at the University of Milan, to propose to the Unacoma Association that a permanent body be set up to allow a periodic exchange of information between countries regarding the sector, analyzed from the point of view of researchers, manufacturers, and farmers. The Club of Bologna, Strategies for Agricultural Mechanization, was founded in 1989 and held its first meeting in November of that year at the 20th EIMA, with the participation of 51 members from 31 countries. The first topics discussed were agriculture and mechanization after the year 2000 and process and production innovation in the sector. Throughout the 90s, the club met annually in Bologna in November, in conjunction with the EMA exhibition, anticipating and addressing meeting after meeting all the main themes that have characterized world agricultural mechanization. In '94, a special session of the club was held in Milan for the 12th World Congress CIGR. All this took place in a context that saw the sector evolving towards a more sustainable mechanization, based on the reduction of polluting emissions and production inputs. The main themes included respect for the soil and reduction of compaction, with an impact on techniques and consequently on machines for soil tillage, but also on conservative agriculture and reduced tillage. These years saw the development of technologies for input distribution, aimed at limiting waste and losses, reducing air and water pollution, as well as machines for distributing pesticides and mineral and organic fertilizers. These were also the years in which, with the Kyoto Protocol, nations began to discuss on the future effects of global warming. And another issue in the limelight was the use of new fuels, such as biodiesel and bioethanol, as alternatives to fossil fuels, and the use of biomass for energy production. The research was also concerned with effective strategies for technology transfer and mechanization evolution in developing countries, based on sustainable models specific to each production scenery. Electronics and onboard computers are increasingly being used on large self-propelled vehicles. The advent of electronics in agricultural technology represents a milestone in the development of new types of tractors and machines. Through electronics, technology becomes intelligent and able to communicate with the operator, compared to the past, where the human being acted as the link between farm management and mobile units. Technology becomes an integral part of this management process. In 2000, the Club of Bologna continued its activities, growing in number of members and countries represented. In 2008, an alternation of meeting venues was introduced, which would continue to be held in November, but in Bologna during EMA in even years, and in Hanover, Germany during Agritechnica in odd years. Special sessions were held in Brazil and Japan in 2000, in the USA in 2002, and in Russia in 2007. In recent years, agricultural mechanization has taken on a role considered fundamental in the development of emerging countries, and the main key factors at the global level for increasing the competitiveness of the agricultural sector are the training of workers, the reduction of production costs, the renewal of fleets, and the adoption of precision agriculture. The primary objective is also to ensure the long-term supply of food to the inhabitants of the planet. And in addition to incrementing the quantities produced, machines must ensure an increase in yields and an improvement in product quality, and economic sustainability increasing, a reduction in inputs, and in the impact on the environment. A truly epoch-making challenge that can be summed up in the concept of producing more with less. In the agriculture of the most advanced countries, modern agricultural machinery is an increasingly important tool for the security and healthiness of agricultural products, and the first indispensable step towards their traceability. Thanks to the development of mechatronics and IT, information technology, increasingly advanced software is being implemented on tractors and self-propelled machines, capable not only of controlling basic functions, but also of customizing and optimizing the human-machine interface. Many simple or sequential operations are handled autonomously, reducing driver fatigue and stress. Increasingly reliable and advanced sensors and data collection systems are being installed on harvesting machines. Software is becoming a fundamental component of agricultural machinery, essential for its maintenance and repair, also thanks to the remote control of fleets. Meetings between Italy and Germany continued in the tens, with a special meeting, Farm Mechanization to Feed the Planet, held in Milan during Expo 2015, whose concluding remarks, agricultural production and related technologies play a fundamental role in ensuring food security, were collected in the Milan Charter for Mechanization included in the official closing document. And another event of the club was held in 2019 in Morocco as part of the second conference of the Pan-African Society for Agricultural Engineering. In 2016, for the 25th meeting, an overview session was held on the evolution of the sector in the years being considered and its prospects with the production of a dedicated volume. 4 specific study groups have also been set up in recent years, dedicated to sustainable agricultural mechanization in Africa, ethics of agricultural mechanization development, and the dissemination of club activities and the evaluation of the incentives for the improvement of the agricultural mechanization in the world. In this decade, research in the field of mechanization developed along the lines of automation, robotics, and the application of IT. This development can be compared to the revolution that took place in the 1950s and 1960s with the introduction of the tractor, the combine harvester, and other types of machinery that revolutionized agriculture at that time. As in the automotive sector, there is a lot of investment in electric or hybrid engines to replace diesel engines. There is a growing market for systems that are more economical, environmentally friendly, and optimized for operations, saving resources such as fuel and pesticides. The watchword is precision, which in field operations becomes a prerequisite for optimizing crop yields and quality, as well as minimizing production costs. Assisted driving and control systems based on RTK technologies are becoming more widespread, onboard sensors more sophisticated and reliable, and the first models of self-driving vehicles are appearing on the market. At the same time, there is a need to update and define new technical standards to keep pace with new technologies. The new paradigms for agriculture and the first and foremost for mechanization are smart farming, digital farming, agriculture 4.0, and the Internet of Things. Information technology is becoming part of everyone's daily life and has many applications in this sector too. Thanks to increasingly effective use of IT, it is possible to optimize inputs with precision farming, manage mechanization and the use of energy resources more efficiently, improve yields and reduce harvest losses, provide better information on market demand and bring the market closer to producers, improve support services, transport, and logistics. In 2012, the year of the club creator's death, the Pellizzi Prize was set up to honor his memory. The prize is awarded to the world's most deserving PhD degree thesis on agricultural machinery and mechanization, again promoted and supported by Federunicoma under the aegis of the Giorgofili Academy. The prize, now in its 4th edition, has rewarded a total of 14 Italian and foreign researchers. All the winners have joined the club as expert guests, with the aim of enriching the work of the organization with the contribution of new generations. The 30th meeting, which was due to take place in 2020 but was postponed due to the COVID-19 pandemic, celebrates 3 decades of activity with 95 members from 30 countries and a renewed desire to meet and debate. In celebrating the 30th meeting, we would like to remember and thank the presidents who have succeeded one another. Giuseppe Pellizzi from 1989 to 2004, Ettore Gasparetto from 2004 to 2008, Luigi Bodria from 2008 to 2016, and Paolo Balsari from 2016 to the present, and the colleagues, friends who have passed away, to name a few: Yoav Sari, Richard Haig, Luis Leviticus, Jean Luca, Luigi Lisa, Loretta Brega, Arne Moller, Oleg Marchenko, Franco Sangiorgi, Luis Marquez. Great challenges and great projects await the future of the club, in which Federunicoma continues to believe, and which will see the sector face new challenges. Climate change will be a major challenge for the development of architecture, forcing farmers to find solid and sustainable solutions to increase the productivity of their land. The goal is to increase current food production by 50% by 2050, when the planet population will exceed 9.5 billion. Not only will more risks related to weather conditions, water scarcity, and soil degradation have to be addressed, but at the same time investment in crops and farming practices that minimize the environmental impacts will have to be made. The macro objectives in which agricultural mechanization will play a primary role are therefore those of guaranteeing healthy food security and safety for the planet, and contributing to the fight against global warming and to adapt to climate change. Efficiency, quality production, and respect for the environment will be the paradigms of the agriculture of the future. The machines of the future will undoubtedly be smarter, more connected and interactive, and within a few decades, the most advanced companies will come to affirm remote control and guidance. Machines for smart farming, to cope with increasing urbanization and the demand for food, will be complemented by machines for vertical farming and soilless farming, an ideal sector for robotics applications. Augmented reality-based solutions will become more and more widespread. Integrated with artificial intelligence components, they will prove to be indispensable right from the industrial implementation process, while making their use easier and safer in the field. Finally, mechanization will play a strategic role in development and welfare growth in emerging countries. Economic growth from agriculture is at least twice as effective in benefiting the poorest compared to growth from non-agricultural sectors. Mechanization of agriculture can ensure better living conditions, higher productivity, and adequate incomes, counteracting the progressive abandonment of rural areas. The Club of Bologna, in the words of its creator in the year it was founded. A permanent observatory for the study, analysis, and in-depth analysis of the issue of agricultural mechanization at a global level in order to define possible development and evolution strategies according to the current and future needs of the various countries.